A couple things before we get started. I think you might have a typo on your paper. Please make sure that your equation reads plus 20 because that might throw you after. We're going to be talking again about the zeros of polynomials. So we want to remember what the possible rational zeros or the PRZs are. So remember that is the plus or minus the factors of the constant divided by the factors of the leading coefficient. Okay, so today we're going to work on determining all real solutions for the given function. This means the real roots. Okay, but we have to remember the real numbers include the rational numbers and the irrational numbers. The previous work we did on this, all of the zeros we found were rational. They were included in the list of PRZ. Today we're going to work on how to find the irrational zeros. Okay, so again, please make sure that you have a plus 20 here. I'd like you to pause the video right now and go into your calculator and type the expression x to the fourth plus x cubed minus 23x squared minus 39x plus 20 into your calculator, because we are going to think of this side of the equation as f of x or y. So we're going to be solving f of x equals 0. That's why we can use our calculators. So again, pause the video at this point and enter that into your calculator. So I always take some time here and just look and make sure that I typed everything in correctly, because that's usually my biggest mistake, and it's a lot of work to go through just for typing something in incorrectly. So the next thing that we want to do after this is I want to go into second table set, and please just make sure that auto is highlighted. And then I'm going to go to my window, and I actually realized before I change my window, let's figure out what our PRZs are. So in this problem, our PRZ, right, we have plus or minus, our factors of 20 are 1, 2, 4, 5, 10, and 20. And our factors of the leading coefficient are only 1. Okay, so 1, 2, 4, 5, 10, and 20 are our possible rational zeros. Okay, so that probably includes some of them. So what I'm going to do for my window is my biggest number is 20. So I'm going to go a little more than that. I'm going to do negative 25 because my smallest number would be negative 20. And I'm going to do to 25. Okay, and then I'm going to hit my graph. And it doesn't look like anything's happening, but my graph is actually working. And I can see that I do have some zeros. They're pretty hard to read, and I have all this extra step. So this is sort of a trial and error type thing, and what you can see and what you can't see. Your eyesight might be better than mine, but I'm going to change my window again. I'm going to try from negative 6 to 6. That's just sort of arbitrary based on what I saw. Okay, so right now I can see 1, 2, 3, 4 intercepts. And I know that that's all the intercepts that I have because my highest exponent here is 4. Okay, so looking at this, I see that I think I have a 0 at negative 1, negative 2, negative 3, negative 4. So I'm going to write x equals negative 4. Then this looks to me like it's somewhere between negative 2 and negative 3. but I don't have a possible rational 0 that's between -2 and -3, right? I would need one that looks more like a fraction, and I don't have that in my list. So that means this must be one of my irrational zeros. Same with this one. It's between 0 and 1. I don't have a possible rational 0 that's between 0 and 1. And then counting out 1, 2, 3, 4, 5, it seems to me that I have a 0 at x equals 5. So I don't want to, while that looks like pretty good evidence that those are my rational zeros, I always want to check. So remember to check. I'm going to go second table set. It doesn't matter what table start is for this one. I'm going to change my independent to ask. And then I'm going to hit second graph because that gets me to my table. So I'm going to type in -4. I see that I have 0. Okay, so that's good evidence that this is a 0. I'm going to circle it to remind myself that I checked it. Then I'm going to type in 5. I also got 0 there. Okay, so I'm going to circle that because I know that that is also one of my rational zeros. So I need to find my irrational zeros. So what we're going to do here is some repeated synthetic division. So I'm going to start with -4. Okay, it's not the opposite of -4 because we have the value, not the factor. Okay, and then I'm going to put in my coefficients 1, 1, -23, -39, and 20. Okay, so I'm going to complete this synthetic division, and then I'm going to do the repeated synthetic division with 5. So pause the video now, do that synthetic division, and start the video again when you've finished. Okay, I used -4. I had good evidence of a 0 at the end. I used 5. I had good evidence of a 0 at the end. So my equation would factor into x plus 4. Okay, remember the opposite of this, x minus 5. And then this was at the x to the 4th level. This was at the x to the 3rd level. So this is going to be our x squared level. Okay, so that means I have the factor x squared plus 2x minus 1 equals 0. Okay, I know that this is prime because if it wasn't prime, I would have another rational 0. So I know this is prime, so I'm going to use the quadratic formula with just this expression to find my other irrational roots. So pause the video and find your x using the quadratic formula. Restart the video when you've completed it. Okay, I got -1 plus or minus the square root of 2. If you didn't get that answer, pause the video, look at my quadratic formula, and make sure yours matches, right? Our b is 2, our a is 1, our c is -1. I should have a -1 in there, but I think my answer is still correct. Sorry, that was just a typo by me. Okay, so nice thing that we can do with our calculator. You are still in your table. To save yourself a little bit of time, you're going to type in my first exact root, -1 plus square root of 2. So here I'm going to type -1 plus the square root of 2. So the nice sign is I see a 0, which means I found a correct 0. The other nice thing is it gives me my rounded answer. So I can say that x is approximately, we're going to round to 2 decimal points, 0.41. Okay, and then I want to find my other exact answer, x equals -1 minus the square root of 2. So here, -1 minus the square root of 2. Again, I get a 0, so that's a good sign that I found the correct 0. and that was negative 2.41. Okay, so my exact answers here are x equals negative 1 plus square root of 2, x equals negative 1 minus square root of 2. You could write those combined. I'm okay with that. X equals negative 4, x equals 5. Okay, and that makes sense. There are 1, 2, 3, 4 roots. Our highest exponent was 4. And then our rounded answers are x is approximately 0.41, x is approximately negative 2.41, x equals negative 4, x equals 5. Okay, and we can check the graph real quick and make sure that that looks like it makes sense. So looking at this, my leftmost root should be negative 4, negative 1, negative 2, negative 3, negative 4. That seems to make sense. My next root, negative root, should be negative 2.4, negative 1, negative 2, and a little bit more. That seems reasonable. And then 0.41, that would be somewhere between 0 and 1. That seems reasonable. And x equals 5 over here. That seems reasonable. So you have another example to look at after this one. Please work with your classmates if you had any questions. Please mark anything in your notes that wasn't clear to you, and we can go over this when I'm back in class.